All right, let's look at the second partial test. All right, so let's say a comma b is a critical point of f of the first type. So first partial with respect to x and the first partial with respect to y is equal to 0 at that point, a comma b. All right. Then we can compute this quantity called the d, right? Which is defined as second partial with respect to x times second partial with respect to y minus mixed partial with mixed partial squared, right? Then based on d value, we can divide into three cases. First case as d came out to be positive. Second case that d comes out to be 0. And the third case that d comes out to be negative, right? So when d comes out to be positive, it basically says that it's going to have a shape of a bowl, right? And if the second partial with respect to x is positive, and you can actually look at the second partial with respect to y, you can do either way. But the second partial tells you about concavity, right? So it's greater than 0, then you have a bowl facing upward, right? So which means that f of a comma b is going to give you a relative minimum. Because the bowl is facing up and the critical point is right at the bottom. So it's going to be at bottom of the bowl, which gives you basically the lowest value, relative minimum, right? If the second partial with respect to x is negative, right, which means that the bowl is facing downward, right? So we're talking about the relative max, right? Second case, if d comes out to be 0, then this method fails to give you any answer. So this is actually inconclusive, right? Inconclusive means that you cannot make any conclusion. So it could be anything. It could be relative max, relative min, saddle point. It could be neither, right? If d comes out to be negative, then we're going to have a saddle point, right? So let's look at a couple of simple example, right? So let's say you have a 0, 0 for both examples is the critical point. And let's try to apply this second partial test, right? So let's take the first partial with respect to x first, which is going to give you 2x, right? And second partial with respect to x is going to be equal to 2, right? And first partial with respect to y is going to give you 2y. And the second partial with respect to y is going to give you 2, right? And also we need a mixed partial, so partial with respect to x, then partial with respect to y. So if you take the partial of this with respect to y, it's going to be actually 0 because it's considered to be a constant. All right, let's find the d value. In this case, we don't really have to plug in 0, 0 because these are all constant already. So d is going to be second partial with respect to x, which is 2, times second partial with respect to y, minus mixed partial squared, right? So this is going to give you 4, right, which is positive, right? And also second partial with respect to x is positive. So we're looking at this case right here, right? So therefore, we're going to have a relative minimum. So therefore, f of 0, 0, if you plug in 0, so function value is 0, is a relative minimum, right? Let's look at another one, right? So let's find the first partial with respect to x, which is going to be y, and the second partial with respect to x is going to be 0 because the y is a constant. Right, so first partial with respect to y is going to be x. then if you do a second partial with respect to y, it's going to be 0. How about the mixed partial? Right, so we take the partial y with respect to y, which is going to be 1. Right, so if you compute the d value, you can see that it's going to be 0 times 0 minus 1 squared, which is going to give us negative 1. Right, so since this is negative, right, so this tells you that we have this third case right here. Right, so we have, so therefore, if you look at the point, so it's going to be at the 0, 0, f of 0, 0 is also 0, so its origin is a saddle point. Right. Let's open up a GeoGebra so that we can make sure that this is what we actually get. Let's open up GeoGebra. All right, so we got GeoGebra open. So we're gonna go to View and the 3D Graphics, and I can 2D one. You can close it. You can actually close the algebra too. All right. So here is the first one. So z equals x squared plus y squared. Right. So you can see that here you have a ball facing upward. Right. Then you see that here at the origin. Right. This is going to be the local minimum or relative minimum because it's the lowest point. Right. All right, so let's do the do another one. So I'm gonna just open up a new one. All right. All right, the other one that we looked at was z is equal to x times y. All right, so it looks like this. All right, and maybe I'm gonna rescale it. So see, so maybe if we can rescale it, is it easier to see? All right, so it looks, no, it's not easier. So maybe I'm gonna come out a bit. All right. All right, so let's see. All right. All right, so you can see that this is called the saddle point right here. You can see that it's a curving upward here in this direction. But if you look at this direction here, it's a curving downward. So this is called the saddle. You can actually see that it has a saddle shape. So this origin is called that saddle point because it looks like a saddle, right? All right, so that's what they look like, and but this method is called the second partial test. It works pretty similarly to second derivative test that we learned for a function of one variable. All right, that's it. I hope that this was clear.